Good morning. Lesson 1-7, understand rates and unit rates. Oh, remember last lesson I said we were going to get to unit rates? Well, here we are. So after today, you should be able to understand how a rate is related to a ratio and use ratio and rate reasoning to find the unit rate. Remember, unit rate is your per one. All right, let's please go over here to example 1, and we'll scooch on down to the check like normal. Refer to example 1. We've got some information above. The scientists also recorded that a hummingbird took 6,250 breaths over 25 minutes. Assuming a constant rate, how many breaths per minute did the hummingbird take? Oh, okay. Let's use fractions because fractions are really going to be a great way for you to do this as you get older. The scientists also recorded the hummingbird took 6,250 breaths over a period of 25 minutes. And we want to know breaths per minute. Per minute means we want 1 minute. And we want to know how many breaths that little birdie took. This is our goal. This is what we're trying to figure out. Here's how we would set it up. So now we can find our known information. Well, how many breaths did he take? 6,250 in a 25-minute period. Because I labeled it here, I'm not going to repeat the labeling. Let's not make extra work for ourselves. So how do we get from 25 to 1? Oops, I should use a different color. Divide by 25. So what do we got to do here? Divide by 25. 6250 divide 25. 250. Whew. That's a lot of breathing. 250 breaths per minute. Again, English to Mathlish. Label it, set it up properly. You don't have to do this again. I'm just going to show you what it would look like if we didn't put this in the fraction way, if we used a chart. Okay, but again, you don't have to do this, but please do watch it. If you had breaths and minute, and our goal was 1 minute and how many breaths, and we knew that in 25 minutes, the little thing took 6,250 breaths, divide 25, divide 25, and you'd end up with 250. So same thing, just written in a different format. We should start trying to shift over here to fractions. It's a process, okay? Let's look at example 2, the check. So I'm on page 60. A sporting goods store sells a package of 20 baseballs for $25.95 or a single baseball for $1.75. Which option has the lesser unit price? That's money per ball. Money per one ball is the goal. Well, we know that if we buy a single baseball, this information, it's $1.75. Or we need to figure out how much this is per one. So we got to do a little extra work here. So I'm going to set this up. We're trying to find one ball, okay? But it's $25.95 for 20 baseballs. How do we get from 20 to 1? Divide by 20. So what are we going to do? The $25.95? Divide it by 20. $25.95 divide 20. Oh, Miss D, what does this mean? How do we even deal with this? Okay, this is rounding. So let's scooch on over here and we'll show this. 1.2975. If this is money, this is your penny. And we almost always round our money to the nearest penny, okay? So you go to the number to the right. Does the 7 make the 9 go up or stay the same? Yeah, it makes it go up. Well, biscuits. It makes it go up to a 0, which bumps this one to a 3. So this one is approximately $1.30. See the squiggly equal sign? That means approximately. So we round the 7, rounded the 9 up to 30. This 29 goes up to 30. Okay? So $1.30 per single ball. So per ball, which is the cheaper buy? Buy the 20, because then per ball you'd have a lesser cost. So we got to write that in a short little sentence. Which option has a lesser price? Buying 20 baseballs is cheaper. Period. Answer in a box. Find the unit price, money per one thing. And in this case, we were talking about baseballs, so that's why we put the ball on the bottom. Okay. All right, let's see if I could turn you loose yet. Let's maybe try this check. We're only at 6 minutes here, so let's try this. A runner is training for a half marathon. On Wednesday, she ran 6 miles in 50 minutes. Excuse me. On Thursday, how do I want to set this up? Let's see. Miles and minutes. Miles and minutes. So on Wednesday, we have Wednesday, she ran 6 miles in 50 minutes. 6 miles in 50 minutes. Now watch me leave a space here. Watch me leave a space. I'm thinking ahead. On Thursday, she ran 4 miles in 32. Thursday's an R because if it's a T, it's a Tuesday, right? So on Thursday, she ran 4 miles, and that took 32 minutes. Assume she ran at a constant rate each day. On which day did she run faster? That means we need to figure out one of these needs to be same. I kind of like to know how fast she can do 1 mile. So let's find for 1 mile, okay? On Wednesday, how do you get from 6 to 1? That's right, divide by 6. So what are we going to do to the 50? Divide by 6. Is it going to be an even number? Absolutely not. 50 divides 6, 8.3, and then the 3 went on forever. Okay, means it took 8.3 minutes for her to run 1 mile. And on Thursday, how do we get from 4 to 1? Divide by 4, 32 divided by 4 is 8. So which one's faster? The smaller number. Thursday, she ran faster by 0.3 minutes, which is really 18 seconds per mile, but you know, it is faster, so let's write it. Oh, and by how much faster did she run? Oh, this will be great. She ran faster Thursday by 0.3 repeating minutes, which is approximately 18 seconds. How do we do that? Well, we subtracted, you guys. We subtracted 8.3 minus 8. Okay, bink. Answer in a box. All right, good luck. We've got one more lesson in this unit.